So this is the Imagination One API for All Platforms presentation about Vulkan. It's first in this series. So I'll just cover who I am and what this series is. So I'm Tobias. I worked at Imagination Technologies for 5 years. 4 of those years I spent in dev tech, working on our PVR text tool, as well as aiding developers with graphics issues. A lot of time I spent debugging OpenGL or wondering how I could get more performance out of the API, either with extensions or just different mechanisms. And I'm now working on Vulkan and related extensions as well. So I've been working with Vulkan since we first started working at Kronos. So I'm quite familiar with the API. I actually started looking at this sort of stuff a while before Vulkan was even conceived. I'm also developing extensions for both OpenGL and Vulkan. OpenGL right now because it's still relevant and there's still a lot of life left in it. But as Vulkan progresses and becomes available, you can start expecting to see Vulkan extensions from us as well. So this series, I'll give you the rundown now because this is the first. The idea is it's going to be a detailed look at Vulkan. So I'm not going to give any new information out about it. It's just going to be what we've already discussed. What does that mean? And I may be able to give you a little more insight into this sort of thing. It is basically adding context to it. If you missed my talk at SIGGRAPH or anyone else's talk during the SIGGRAPH Birds of a Feather for Kronos, there's a link below which should take you to the right place. I suggest you watch it after this if you haven't seen it already. The topic of this week will be, what does one API mean? So I'm also going to just say I will take questions. If anyone wants to use the Q&A feature, I will take questions at the end of every section. So feel free to post stuff. One thing I will say, there are no gnomes in this presentation, I'm afraid, for anyone who's expecting gnomes. I apologize, but there will be gnomes in the future presentations. It does seem there's about 20 seconds of lag, so I'm going to give 20 seconds at the end of each section as well for questions, but I'll skip that for this one. So what does one API mean? And this is just a sort of quick rundown before I launch into the detail. But by one API, I'm basically referring to the fact that Vulkan should be consistently available. There's going to be a wide range of targets to be able to support and basically a large market share. So many platform vendors, which I'll cover later, have said we're in for this and you're going to be able to expect this on multiple platforms, multiple operating systems, and every relevant GPU vendor that I'm aware of, at least, is within Kronos making this API work for them. So there's a lot of support for this, and there's also support from ISPs and stuff. But this is all about availability this week. And the idea is that you should have consistent experience with the same API everywhere, while still allowing differentiation of different targets. So you'll be able to describe the platform and allow informed choices about how you render something. So that's the quick overview. If anyone's got any questions about what I'm talking about at this point, feel free to ask and I'll try and respond. Like I said, there is a bit of lag, so I will wait just a second longer. Okay, well, I'm going to assume nothing so far then. If anything pops up in a second, I will come back to it. Okay, so what is actually consistent? So the first thing that should be consistent is actually coding to the API. You're going to have the same library of core functions. You'll link to effectively the same library and you use the same header across all your platforms. You'll write the same code. You won't have to have preprocessor shenanigans to deal with subtleties and differences between APIs. For instance, OpenGL, OpenGL, very similar APIs, but the same core spec at the heart of it. There are subtleties between the two APIs, which often require things like using preprocessor macros to define what you're actually doing, which you shouldn't need. This Vulkan is one API. You'll be able to write a single code path through everything. One of the key tenets of this is that there's only a few ways to do things. OpenGL and OpenGL both had quite a lot of ways to do something. Data upload was a notoriously difficult one. A lot of people get it wrong because there's so many different options available. And the actual right answer could quite easily vary by vendor. Some vendors would say use buffer data uploads, others would ask you to map it, others still would even say for certain paths just use client memory. And the trouble is with that, it leads to everyone having to do a ton of ifs in their code, go if AMD do this, if NVIDIA do this, if Imagination do this, etc., etc. Vulkan has limited these, and we've talked a lot about what all the paths are, with the aim that the same path should be pretty fast on everybody. So there shouldn't be one slow path and one fast path, and that vary by vendor. It should be the same one for everyone. And this means that you should be able to have one thing that you can point out in the API and say, this is the way to do it. So for instance, clearing a texture. The best way in the API right now is to use the render pass load operation. So at the start, when you start a render pass, you can say, I want to clear this texture to this color. And that's the fastest way to do it for everyone. It doesn't mean there isn't another way that isn't equally as fast, but it means there shouldn't be a slower path. There's still scope for doing hardware-specific optimizations, but it's really not as necessary. Whereas if you look through an engine today, you're likely to see lots of, like I said, if paths for different vendors. You're not going to have it as much. They'll still be there. Everyone's going to have their slightly faster than everyone else paths and their extensions, whatever else. And you might get the last few percent, but it shouldn't be a fundamental problem of my app runs slowly unless I do it. And this is going to be, I mean, so you still use this for cutting edge techniques, but everything else, generic, not even generic, quite a lot of rendering a good looking application should be doable without going to each hardware vendor's recommendations. So again, I will just pause a minute for questions if anyone has anything. Sorry. Okay, I will continue. So differences. Like I said, you still want to be able to differentiate your platforms. And while a lot of it is going to be very consistent, there's still bits of the API that may vary, but they should be in predictable ways. So for instance, there's some stuff where functionality is optional. The reasons for this can vary between platforms or whatever else for any other reason. Typical things are things like power efficiency or area reasons. So you're not going to get the same feature set necessarily in a smartwatch that you'd get in a desktop workstation card. There's other stuff that could cause this differentiation. You know, there's no market need for a feature as determined by someone. But the functionality to express this exists within Vulkan. And when we say optional, we do mean optional. You still get really good looking apps without these features. It's things like, tessellation. Some apps use that well, but it's certainly possible to write a good looking app without it. And one of the new things that comes in Vulkan you didn't have in OpenGL is the ability to enable features explicitly. One of the first things you do when you start up, say, OpenGL is you create context. And this is a very poor analogy because contexts are horrible. But Vulkan has devices, and this is a logical connection to a device, so a GPU. For instance, when you actually create that logical connection, you have to say exactly which features you're going to use if they're optional. It's not like the entire API is optional. There's a whole load of stuff that is core and cannot be turned on or off. But this other stuff can be. And that gives us a lot of wins in terms of validation. So if not everyone supports it, a validation layer can go, you didn't turn this on, thus your app is incorrect. And equally at runtime, a driver can go, well, you've asked for a feature, we don't support it, you've queried it, you've ignored the query, we're not going to give you advice, and thus your application fails at the first point it possibly can, which means you have a very early warning that, oh, I'm doing something wrong, which is quite nice. And the whole point of this is to avoid accidental use. So moving to the next slide. So limits, again, very similar. OpenGL did have these, OpenGL had this. It's just things like the maximum texture size, how big a render target you can have, what the maximum allocation size is, it's things like that. And Vulkan will describe in some form minimum values for all of these. So there will be consistency in that you can rely on a set of values, but there's scope to expose higher things if your hardware supports it. And again, this is a Chronos API, and I think I briefly mentioned this earlier. There will be extensions. These are really great for prototyping features or exposing stuff in your hardware that's not in core. This is very similar to other Chronos APIs. So you're going to have vendor extensions, so like something like PVRTC. You may have multi-vendor extensions, things where you've got collaboration between multiple hardware vendors, like Pixel Storage, for instance. And there's also going to be Chronos ratified ones, where everyone agrees that in principle it will work. But it's basically it's a prototyping thing. You know, you can try something out. If it didn't work later, you can then move the thing that you think will work into core. Or it might be that it's permanently not everyone's going to support it. So you might say, yes, this is really good if you're a tile-based architecture, but it's never going to work on IMR. Fine, that can be Chronos ratified. Well, I say fine, that's up to the working group. But in principle, that's the sort of thing you might expect. And again, as with optional features, these must be explicitly enabled, which is absolutely fantastic news. You can kind of think about this sort of how in GLSL, for instance, you would have the hash extension or pound extension if you're American to enable and disable additional extensions. And this is, again, at device time, and so you've got the earliest possible point of failure. This is quite a lot of variability, and we're aware of that. So while we haven't put anything explicit into the API, we have got this concept of a feature set, which is basically it's a named set of guarantees. So it may guarantee some limits, it may guarantee what extensions you've got supported, it might guarantee that certain features are always available, although you'll still be able to turn them on and off. And it's not explicitly part of the API, like I said, there's nothing in there that says turn on feature set blah, and Chronos hasn't actually committed to calling out any yet, because we really want to focus on getting the technical bit done first. The actual feature sets tend to be more of an ecosystem question, although we've obviously got to mind with what they might be. And the idea really is that profiles are intended as a guide. As I alluded to earlier, you wouldn't necessarily get all the same features in a smartwatch that you get in a graphics card or on a desktop, and that's for a good reason, and that is efficiency and, again, area, power, etc., etc. And whatever comes out, it will be a guide as to what fits the thing you're looking at best. It's not that, oh, it's got more features, therefore it's better, because better is somewhat subjective. Like I said, you know, you may really want an efficient platform. You don't want a wristwatch that burns your hand off in 5 seconds and then battery turns off. That's not what you want. You want something that will keep you going for a long time. Whereas on the desktop, you've got a 300-watt power supply. You just want all the features. And the final one, yes, the final thing that's worth noting is platform integration. Now, really, this is sort of consistency as well. The reason I'm highlighting it here is because I just want to highlight how we've taken a different approach to what we did with EGL for OpenGL and GLX and WGL before it. So platform integration is going to be defined as an extension. It's not necessary for Vulkan implementation, so effectively you can run Vulkan headless and just do, you know, just run with frame buffer objects instead of actually having a window to present stuff to. Or say if you just want to use Vulkan for single queue work, that's fine. You don't have to do all this unnecessary setup of EGL like you would have to do for OpenGL. You can just go, right, create a Vulkan device and then do some compute work. Done. No real issues. You just set up the same as you would for any other application. And there are some core extensions to this. I probably should have thought the wording better for that. That doesn't make much sense. When I say core extensions, I mean extensions that are relied on by all the Windows system extensions. So there's one that's sort of the swap chain and, or two, sorry, swap chain and surface extensions, which give you the basic functionality of how a Windows system glues to Vulkan and how it creates images, acquires and presents them. And then there's platform-specific stuff, which is where the differences creep in, where each different platform that is going to interact with the main WSI extension is able to define whatever makes the most sense for its platform. And we've had input from these platforms to say, we need these bits to tweak and these bits to turn on and off. And so there's different subtle differences in all of these, but you'd have to integrate with the Windows system anyway. So there's going to be differences based on which platform, regardless of whether we try and hide them via a single API or not. If you want more information, I strongly suggest you look at Alan Orbach's talk from the BOF. He's the working group chair, well, subgroup chair, I think, for the WSI stuff in Vulkan, and he did a very good rundown of what it is and why it's different to EGL and how it differs, which is quite useful. So that's everything I've got to say on consistencies and differences. Does anyone have any questions here? Okay, yes, I've got a question. Hang on. Two questions. Right, so the difference between optional features and extensions. So an optional feature is, the line gets a bit blurred when you talk about KHR extensions versus optional features, but with optional features, the aim is everyone is going to support it, everyone wants to support it, but they can't necessarily support it right now, or they, they're not going to have it on every platform. And the aim with putting it into the core rather than making an extension, so that's the important thing here. It's not in a separate extension document, however that looks. It's part of the core API, so it's defined by everybody. And there's sort of two reasons. So like one, I said it might not be supported everywhere, but it is a good direction. Everyone agrees it's a good direction. And the other reason is that turning it on and off may actually have a performance impact in some people's implementations. So you may find that if you turn tessellation off on a platform that supports it, the driver might do less work to try and make tessellation work in terms of ignoring state or not setting stuff up. So there's a difference there. Extensions, on the other hand, are completely ad hoc. You can do whatever you want in an extension if you're a vendor, and they can come and they may not ever make it into the core. Even a KHR extension potentially has the potential to never make it into the core, whereas the optional feature is in core. And we basically, as an industry, a working group got a working group said, this is good, we will do this, as opposed to this is probably good, we'll try it out. That's what it boils down to. Hopefully that answered the question. Let me know if not. Is this the first standardization project that involves so many members from diverse industries? That's a hard question to answer rather. There is quite a lot of push on this. Certainly, as far as I'm aware, within Kronos, this is probably the biggest project that's been undertaken with quite such a diverse range of people. We've had, when we've been shouting about it, a lot of people from various sectors within software vendors. We've had every single graphics vendor, again, that I'm aware of, is participating. There's no sort of segregation between OpenGL and OpenGLAS, although that was always fairly loosely defined beforehand. But everyone is in one room, and the working group meetings are huge. So I wouldn't necessarily say it's the first in ever, but it's certainly unique or semi-unique within Kronos. Again, as far as I'm aware, I believe OpenGL, I think, came almost as close, but it seems to have leveled out, whereas Vulkan sort of shot up. So that's my take on it anyway. Hopefully that answers your question. Okay, right, I'll move on to platform support then, unless anyone else has any questions in the next 2 seconds. No? Okay, so platform support. So Vulkan is designed to run on a platform, and we've had some input from basically all of these vendors-ish. I say ish. So there's been representatives from all of these OSs in the room in the working group meetings, except for Windows. I don't want to, tell you all the Microsoft's been doing stuff. They're not involved. So Windows support is going to come via hardware vendors that actually support Windows, much in the same way that you get OpenGL 4.3 support on Windows, because the hardware vendors give you access to it. It's nothing core in Windows that actually gives you that. It's just that they can put their libraries onto that platform and allow you to use it. I mean, the same will be true for other Linux distributions. You may see various other Linux distributions where some hardware vendor comes along and goes, look, here's my open source driver, or here's some binaries for this Linux distribution. And these are all totally possible things. So it is worth noting, however, that at least Android has definitely said it's going to be a very core part of Android in the future. Valve is quite intently behind it. The other vendors on this list, Samsung, Tizen, Red Hat, and Ubuntu, Canonical, even, they're all behind this, and they've all given valuable input. So with those WSI extensions I mentioned earlier, you're going to see versions of that for all of these platforms. I can take questions here if anyone has any. I'm hoping there won't be many there. I don't expect many. In fact, I will just move to the conclusion. But if you have any questions, I'll definitely take them after that. So the main takeaway here is that it's not limited to a subset of platforms. So you've got things like Metal on iOS and OS X. You've got DirectX on Windows based on Microsoft-based platforms. Vulkan should have quite wide adoption, as the previous slide should have shown. And potentially by targeting it, you're getting a slice of a very large market share. Software vendors certainly. In the future, Vulkan should get widespread adoption, and by making a game work with it, you should be able to have a large section of the market open to you. There's a lot of interest across the board from platform vendors, GPU vendors, and software developers. So we expect a very large ecosystem to develop over time. Certainly, Kronos is going to do its part to try and foster something there, to seed it with various bits and bobs. We've talked about what sort of things we need in an ecosystem to get it going, and certainly once we release, our job is not over. We'll release a spec, and then we'll just be working on the ecosystem, as well as the next version of Vulkan, I suspect, as well, and various extensions to pop up. Vulkan is set to make quite a big impact on the industry, and I'm going to cover how and why in the next few talks, and so please feel free to come look at those as well. I mentioned ecosystems, so PowerVR, we're certainly going to be working on an SDK and tools for Vulkan as best we can. We've also got a support portal there which you can ask us questions about, and we'll be trying to support on Vulkan from the get-go. Our developer support team are learning about Vulkan as we speak, and they plan to be right on the ball on that. So you can certainly ask questions there as well. We've also got the blogs where all these talks, these webinars, I will be putting a blog post out a few days before. It will usually be just a few days before. This one was special because I was actually at a working group meeting. But usually it'll be, I think, Wednesday or Thursday. I can't remember, but the schedule should tell you that. And we've also got announcements about this sort of thing on Twitter. So you can follow Imagination Tech and PowerVR Insider Twitter feeds, and you'll get information about both, well, anything graphics related, really, as well as other stuff that's going on in our company right now. But certainly there will be Vulkan updates from there at various points. And that is the end of the presentation. So if anyone has any questions, feel free to ask. And I've lost everything. There we go. How close to 3? Yeah, I was actually surprised this question didn't come up sooner. So plan of record is still the end of the year. I can't give an exact date because we don't know an exact date. All I can say is we're working really hard to try and get it out when we said we're going to get it out, and I think we can do it. Personal opinion. I don't see any. Basically, unless we say otherwise, you can expect it end of the year. What end of the year means precisely, I cannot say, but that is certainly still the plan. I will give everyone a couple of minutes in case they have any other questions. I'm certainly willing to sit here and answer for a while. Oh, it's worth saying as well, if you do have any questions and afterwards that I don't answer, you can also contact me on Twitter. Probably should have put this up somehow. Can't remember how do I do this? I'm afraid I am new to Google Hangouts on air, and I'm not actually sure what to do. But I think I can do it this way. Can I do it this way? No, that doesn't work. There we go. Right. If you go onto the Showcase app, I've put a link to my Twitter feed, which you can have a look at as well. There's also links to the Imagination Technologies page and our Google Plus group as well, which I didn't actually put on the slide deck. Although they're company slides, I will have to fix that. More questions. Excellent. Mesa. Okay. I think they're looking at it. I think you'd have to ask them, though, what their plans are. I'm not 100% sure. And even if I did know anything, I wouldn't actually know whether I could say anything. I would probably talk to people like some of the more prolific people in Intel, like Ian Romanek, maybe? Is he in ASA? I can't remember. I'm sorry. I'll try and find out if I can say anything or find a website to point you at. And if I do, I'll put it in. I'll either put it on this page or I'll put it on my Twitter feed and retweet it. And I'll get Power BI Insiders to retweet it as well. Are there still any major issues holding back Vulkan? I don't call that quite a broad question. I mean, not really, no. I mean, certainly we've been internally battling with a lot of stuff for a long time. I mean, we wanted this API to be consistent and have consistent performance. It's very hard to argue with everyone in a sort of 60-person plus room that this is the best way to do something. But we've really whittled it down now. I don't think there's anything major holding Vulkan back, no. We're really just sort of at a sort of niggling over the detail stage, which is, you know, some say 90% of the work, but it's a good place to be in. Driver source for IMG chips. It's certainly come up in conversation. I don't know what the plans are at the moment. Technically, is within our team's remit to do that. It's not my decision. I will clarify that, so don't pester me. And you can pester me, please not too much. But I think we're really focused on getting the closed source one first done, and we'll probably talk about it after that. We're sort of still evaluating our open source plan, I think. So as soon as I have any information, I'll let you know. Again, that will probably come out via the Imagination Tech and Power BI side links. Right, there's no more questions on my list, so I'm going to call that it. If you've got any other questions, like I said, you can either contact me on Twitter or go to our Google Plus page or on the blog. Spoke too soon. Here comes one. Will major desktop GPU manufacturers have drivers ready for release day one? Okay, well, I can't speak for them, but I would be very surprised if they didn't, is all I will say there. I suggest you ask people like Graham Sellers. Yeah, I'm going to stick Graham Sellers in it. Talk to Graham Sellers from AMD or NVIDIA. I'm not sure who to talk to there, but I know at least Graham Sellers should be able to point you at people. Jeff Bowles, yeah, what the hell? Stick him in it too, NVIDIA. Find them on Twitter. Yeah, lovely question. I don't know. Apple are very secretive about everything they do. Certainly, I have no information. I don't know. Afraid I can't answer any better than that. Sorry. So I guess the answer is no. I don't know. Although I certainly would hope they would, but I have no idea. All right. Since that came in last minute, I will give another minute or so for people to ask questions. like I should have filler slides to fill the silence. But I'm going to say that it doesn't. I'm going to say it because last time it made questions appear, so I'm going to say it again. Doesn't look like there's any questions, so I'm going to give it 5 seconds, and then I'm going to say we're done. Okay, we're done. Yeah, again, Twitter, Google Plus page, blogs, any of those places, I'll try and find information out if you ask questions there. We've also got our support portal where you can ask questions as well. Thank you for watching.